Hello folks, today I am going to talk about a combination of resistances. I will talk of several combinations which is possible in exams or even in theories also. So the first combination is in series combination. So in series combination, if we have three resistors, we will have Rs equal to R1 plus R2 plus R3. Easy formula. So if we have two of them, I will have R is equal to R1 plus R2. In case of a parallel combination, what I will have is, in case of parallel combination, so for three resistors, I will have 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So if I change this into directly into Rp, it will be Rp is equal to R1 R2 R3 whole divided R1 R2 plus R2 R3 plus R3 and then R1. And if I have only two resistors, I will have 1 by Rp is equal to 1 by R1 plus 1 by R2, and Rp will be directly, it is R1 R2 by R1 plus R2. So these are the basic formula of series and parallel. Now, what if I have some mixed combination? For example, if I have a combination like this, so if there is one resistor R1 like this, another resistor R2 like this is R2, and then I have got R3 here, R3. So what happens is, first I have to consider the parallel combination of this thing. So let me name it as R prime. So R prime. So this circle will be now equivalent to this will be R prime, and this will be R3. This is R3. So this whole thing will be R prime and this is R3. Now the total will be equal to, so this will be the R total, this is R total. Now this R prime will be equal to, since it is the parallel of R and R2, I must have this R prime is equal to R1 R2 by R1 plus R2. R prime equal to somewhat like this. So that's why here now my R total will be equal to this R total will be equal to R1 plus R3, since it is in series. So it should be equal to R1 R2 by R1 plus R2 then plus R3. Now I can take LCM, or I can just put it as it is. There is no such strict requirement. So my special interest is if this thing, so if all of them are equal to R, all of them are equal, then I must have this R total is equal to, so let me substitute all of them equal to R. So it is R into R by R plus then again R. So this thing will be equal to R square by 2R plus R. So this will be R and R gone. So it is R by 2 plus R, which is 3R by 2. So if I use it, if I use all the resistors of same value, then it will be 3R by 2. So in number 2, my combination will be somewhat like this. So let's go for number 2 here. So now in number 2, what I have is, if I have this sort of combination, then what I will have is, so this is R1, this is R2, this is R3. So here, let's first think of this. These two resistors will act as one. So it will be equal to, so this is one resistor. Let me say this is R double prime and this is R3. So this is R3 and like this. So I'll have, so this is equal to, it is R total is equal to, so R total is equal to parallel of R double prime and R3. So it will be equal to, so first let us find this R parallel here. is equal to, so R double equal to R1 plus R2 So this will be R double prime R3 by R double prime plus R3. So it's equal to R1 plus R2 R3, and then it is R1 plus R2 plus R3. I can use a bracket here, or I might not use the bracket as well. So if I use all the values as same, R1 equal to R2 equal to R3 equal to R, then the value should be equal to this R total will come to be equal to, so let's see all the values. So it is R plus R, R, again I have R plus R plus R. So it's equal to 2R into R by 3R. This goes. So it's equal to 2R by 3. So mixed combination. So one is first two parallel, then in series, first in series, then in parallel. Now, all of them need not be of combination. Some might be just some modification of series or parallel. For example, if I have this sort of circuit, if I have this sort of circuit here, like this, so like this, and like this. So if I have this sort of circuit, this is R1 and this is R2. Now the resistance total will be 0 here, because what happens is, if this is plus and this is minus, the plus charge will first come here because it fills resistance R1 there, and after coming here, it goes here and goes here and goes here and goes here. It does not go through any resistors because it is finding the easiest path along the way. So that's why the total R will be equal to R total is equal to 0. If I have another arrangement like this, and here I have this thing, here I have this thing, and like this. So this is R1 and this is R2. Here also the value of R total will be 0 because current will find the easiest path here. It does not go through R1 or R2. So I will have R total is equal to 0 once again. And again, if I have this sort of arrangement, here also, I will face the same situation like this. So if I have this sort of thing, again, whatever be their values, R total will be equal to 0 because the charges simply go through this path. So other resistors are just useless. So here also it is 0. Now, as you go on modifying, some differences now arise. So if I have this sort of arrangement here, so I have this thing, I have this thing, I have this thing, and now I have this thing. So this is R1, this is R2, this is R3. So in such arrangement, what happens is, current passes through both of these branches, but when they come here, they bypass this R3. They simply go like this. So R3 is useless. So that's why the circuit will be simply like this, So R total will be equal to, it is R1 parallel R2 equal to R1 R2 by R1 plus R2. So then number 7. In number 7, again, if I have arrangement like this, now things are becoming a bit complex here. This arrangement, then now this arrangement here, I have resistor over here, and then again I have resistor over here. If so, this is R1, R2 and R3. Now what is happening here is, this is a bit mysterious here because the three resistors here are now in parallel arrangement. They are now in parallel arrangement. It doesn't look like so, but they are in parallel arrangement. So how? Let us see. So let's name these points as A and B, these points as C and D. So A and B are common points and C and D are common points. So that's why what I can do is, from here let me name it as, this is A comma B, and here it is, let me name it as C comma D. Now what happens is, from A or B, from A or B, there are 3 branches. One branch is this, one branch is this, one branch is this. And all those 3 branches converge at C, D. From A, D, 3 branches, and all 3 branches converging at C, D. So that language speaks enough, I suppose. So from here, I have to produce 3 branches, and all these 3 branches are converging at C, D. And our only job is to fill these resistors. So this is R1, this one will be R1, then this one will be R2, and this one will be R3. So this is R3. So what happens? From A or B, 3 branches arising, all the branches converging to C and D. So we have the parallel arrangement here. And again, number 8, in number 8, I have this arrangement. If I have this thing, and this thing, they are in series. So, but if I connect them like this, now they again become parallel. So this is R1, R2, and R3. So now what happens if I give names like that? So this is A, this is B, this is C, and this is D. If I give names like this, so from here, so A and C, they seem to be same point. So what I do is, from here, A, C. Now from A, C, there arises 3 branches. Let us show. One branch is this, one branch is this, and one branch this. One branch this, one this, and one this. And then, after going through the resistors, all of them converge at B and D. Once again, they converge like this. So this is B, D. So this converges here, and this converges here. So what is happening here is, from here we have 3 branches, 1 branch, 2 branch, 3 branch, and then we have 1 branch, 2 branch, and 3 branch here. So that's why the arrangement will be like this: 1 branch, 2 branch, and 3 branch, 1 branch, 2 branch, and a 3rd branch here. The resistor will be somewhat like this, resistor will be somewhat like this, and resistor will be somewhat like this. So this is let us say this is R1, R2, and R3, again parallel. So they seem to be different, but they are in reality they are parallel resistors. Then in number 9, I have one more arrangement here, one more arrangement of the same type. So I have got this thing here, I have got this thing here, and then I have this resistor, but here it is a short circuit. There is no resistor. So this is R1, this is R2, this is R3, this is R4. Now, what I can do here is, I need to solve this circuit. So what I should do is, I have to see the seriesness or the parallelness of the different branches. So what happens here is, let me name it as A, name it as B, name it as C, and name it as D. So now what is happening here is, let us see, from A, this is A, a branch goes like this. This is R1, and it goes to B, C. It goes to B, C. Then from here we have one thing going to R2. This is R2, and from R2 it goes to D. Now from D we have 2 branches emerging, and both branches are converging to B or C. From D we have 2 branches emerging, and both branches converging to B or C. So I have this, and both of them converging to B or C. So this is R2, this is R3, and this is R4. So this is the accomplished situation in which R3 and R4 in parallel. This is in series with this, and the whole thing is in parallel to this R1. So from there you can solve the circuit. So in this way we have several combinations, and with those combinations we can change them into series or parallel, and then solving is not an issue if we know that particular formula. The main thing is that we have to manipulate things to see seriesness or the parallelness of the given arrangement.